students, welcome to Sringeri College YouTube channel. And today we are going to discuss or we glance some properties of Laplace transform. In previous video, we have discussed properties of first shifting and derivative of transformation. So, when examples in a combination of shifting and derivative property and how to solve. So just we glance here properties of Laplace transform. In previous video we have already studied. So first shifting property, that is if Laplace transform of f of t is equal to f of s. It means so f of t is a time domain function. If you apply the Laplace operator on time domain function, we get in a frequency domain. It means we get answer in frequency domain. Then Laplace transform of exponential form e to the power at is multiple with the time domain function f of t, and we get f of s minus t. So any function of time domain is a multiple with the exponential of e to the power at, then we get s as changes as s minus a. Suppose here a is a minus, then s changes s plus a. So this is the property of shifting property we are already discussed in previous video. And this another one property is that second property, that is derivative of the Laplace transform property. Same, that is also we have seen in previous video. So suppose Laplace transform of f of t is equal to f of s, then Laplace transform of t to the power n t to the power n f of t. When time domain function multiple or product with the t to the power n, we get minus 1 to the power n, and n the derivative of f of t, that is we get in frequency domain f of s. So this property also we discussed in previous video. So with the help of these two properties, and today we are going to discuss examples on shifting and derivative property. When a combination of these two property, when we have to apply the combination of these two property in examples. Let us start with an example. We discuss or we solve few examples on these two properties. First one is find first example, find the Laplace transform of t e to the power minus 2t sine of 4 times t. So look at this example. Here sine of sine of 4t and e to the power minus 2t and t is there. It means this example is a combination of these two properties. So first we have to solve e to the power minus 2t and sin t. So apply this property, and after whatever you get the answer, and that answer is multiple with the t. It means we have to apply the derivative property, that is t to the power n f of t. So f of t is nothing but we have to time domain function, we have to find out the Laplace transform of any f of t. So if you treat it as this is f of t, then we apply the e to the power first shifting property, and we know that we have already discussed some basic signals or standard signals of Laplace transform, that is sine of general form of sine of et. So first find out the Laplace transform of sin of 80, it means 40 is a 4, and whatever we get just substitute, and after that apply this property, and whatever we get after applying the first shifting property, so we get some answer, and after that we have to apply the this condition, it means derivative of the transform property. So solution, very simple solution. So this is whole thing is our f of t. Let f of t is equal to t into e to the power minus 2t and sin of 4t. So now look at here, and here I consider f of t is a, I consider here f of t is a sin of 4t. So consider f of t is a sin of 4t, and apply the Laplace transform of f of t and Laplace transform of sin of 4t. So we get 4 over a square plus 16. So this is the Laplace transform of sin of 80. So suppose sin of 80 means a over a square plus a square is there. So just I applied here. These are the basic standard signals of Laplace transform. And now we have to find out the Laplace transform of only these two terms. So Laplace transform of e to the power minus 2t sin of 4t. So now look at this one, and this is looking like the property of first one, that is the first shifting property. When f of t is a multiple with the exponential form e to the power 80, it means just we have to change this thing here s as a s minus c or s plus a. That's it. First we have to find out the Laplace transform of sin of 480. This is the Laplace transform of sin of 480 is 4 over s square plus 16. It means 4 s square plus 16. And now we have to change the or apply the first shifting property. It means s only changes as s minus a or s plus a. Here negative is there, so it means s changes s plus a. It means a is 2, s plus 2. Therefore Laplace just apply here s as s plus 2, s plus 2 whole square plus 16, and after that simplify it. S plus a whole square formula applying a plus b whole square formula, 4 over, so s square 4 times s plus, so 4 square 4 plus 16 means 20. So this is the Laplace transform e to the power 80 sin of t, and after that we have to apply again. So look at here, t is a multiple with this term. It means this is the second, we have to apply the second property, that is the derivative of the transformation property. Hence Laplace transform of t e to the power minus 2t sin of 4t. So this is equal to, and this is equal to, it means, so t to the power 1 is there, n value is 1, it means, so minus of 1 and first derivative of f of s. F of s are repeat form. This is our f of s of this condition. So minus 1 over to the power 1 and first derivative of derivative of the f of s. So f of s is 4 over 4 divided by a square plus 4s plus 20. This is equal to minus first derivative of this term is nothing but we are already familiar with the differentiation of when a fraction form is there or quotient form. So first keep as it is denominator and differentiate numerator term, minus keep numerator term as it is and differentiate denominator term. So we know the basic properties of the differentiation. So minus 1 first differentiation. So a square 4s 20 and differentiation of numerator terms. Constant 4 is a constant, so differentiation of 4 with respect to s means 0 and minus and keep as it is 4 as it is and differentiate numerator terms, that is s square is nothing but 2s and 4s is the 4 and 20 is 0 and divided by a square 4s plus 20 whole square. So this is the minus and whole thing is 0 because any term multiplying with 0 is 0 and here minus take 2 outside minus 8 2 plus not 2 s plus 2 and divided by a square plus 4s 20 whole square. So minus of minus is plus. So this is the answer for the given function, that is t to the power minus 2t and sin t. I hope you have understood. So we look at similar example on the basis of these two properties. Another example. Find the Laplace transform of t to the power 5 t to the power 40 cos hyperbolic 3. So this is also very simple and this one can solve by two methods. So we discuss solution. So let given whatever the condition is our f of t, that is t to the power 5, t to the power 5, t to the power 40 and cosine of hyperbolic 3t. So this is treated as our f of t. Cosine of hyperbolic 3t, we know the general form of the cos of hyperbolic 80. If you apply the Laplace transform or operate on it, we get answer, that is, so cos of hyperbolic 3t is nothing but s over s square minus 9. So this is the signal we have seen in previous video. This is the answer for it. Otherwise we can write cos of hyperbolic 80 in the exponential form, that is also we know that cos of hyperbolic 3t can be written 1 over 2 e to the power 3t plus e to the power minus 3. So whichever is convenient we have to apply and solve it. So better we apply the cos hyperbolic 3t in the exponential form. It is easy to understand or so that is a shortcut method. We don't get lengthy process. If you apply this method means we get the lengthy process. So I write here t to the power 5, t to the power 40. So I apply this method. So cos of hyperbolic 3t is in the exponential form. and that is e to the power 3t minus 3t over 2. So simplify, 1 over 2 take common, 1 over 2 take outside, and e to the power 5. So e to the power 40 into e to the power 3t, it means e to the power 7 times t. Similarly, again e to the power 5, e to the power 40 into e to the power minus 3 is e to the power t. So this is our f of t. Now we have to apply the Laplace operator on it and we get solution. So look at here, apply the Laplace transform. Therefore, Laplace transform of f of t. So take 1 over 2 t, and Laplace transform of e to the power 7t e to the power 5 plus Laplace transform of e to the power t and e to the power 5. So now look at this one. So again, which is looking like the first property, that is when a function f of t is a multiple with e to the power t. Here also same. So exponential form is there and t to the power 5 is there. T to the power 5. We already know that when t to the power n is there, if you apply the Laplace transform for the t to the power n, we get n factorial over s to the power s n plus 1. So apply that one, and after that we have to apply the first definite property. So otherwise, if you want to find out, reverse. First find out the Laplace transform of e to the power 7t, and after that t to the power 5. It means we apply the second property, t to the power n, when f of t is multiple with the f of t is multiple with the t to the power n. So whatever you have arrangement, we have to solve it. So we can solve by the two methods with these two properties. So here I solve with the help of the first definite property. So first I will do and Laplace transform of f of t 1 over 2. So first here I will take first I want to find out the Laplace transform of t to the power 5. So we already know that when a Laplace transform of t to the power n, so this is the standard signal of the Laplace transform, and we can convert this one, that is n factorial over s to the power n plus 4. Clear? This is the Laplace transform of t to the power n. Here also, here n is 5, t to the power 5 is there, so 5 factorial s to the power 5 plus 1, it means s to the power 6. So Laplace transform of here 5 factorial s to the power 6 and now so this function is multiple with the e to the power 7t. It means we have to apply the first definite property. It means s changes to s minus 7. So here s changes to s minus 7. Plus, and again, so look at here, t to the power 5, and is this term is multiple with the exponential of t. It means again same looking like the first property, that is first definite property, and that is 5 factorial over s to the power 6, and here also s changes to s minus 1. S changes to s minus 1. So therefore 1 over 2, 1 over 2, 5 factorial value is 120, and s, we have to change the s here, s minus 7 over 6, and 5 factorial is 120, and s changes to s minus 1 over to the power 6. So take 120 common and we get 60 1 over s minus 7, s minus 7 power 6, and 1 over s minus 1 over 6. So this is the answer for the given function. So we will see some more examples in next video.